So we have f of x equals to 1 over square root of 2 pi exponential raised to power minus x over 2, like this. Now the characteristic function, which is a phi subscript x of t equals to integral 1 over 2 pi exponential raised to power minus x squared over 2, then multiply by the characteristic function, which is exponential raised to power iota tx, then we have the x. So now this is a constant and we can take it out. So we can have phi subscript x of t equals to 1 over square root of 2 pi integral. Now we are left with this. We said exponential raised to power minus x squared over 2 multiply by exponential raised to power iota tx the x. So using the knowledge of indices, we can join these two together and we say this is equals to 1 over square root of 2 pi integral. Now we have exponential raised to power minus. I want to factorize minus out so that here, if I open bracket now, I'm going to have a x raised to power 2 divided by 2. Then here we're supposed to have plus, but because we factorize negative out, then we have a minus iota t x the x. So we say minus times minus will finally give us plus. So now we want to join these two together. So if you take the LCM, we're gonna have 1 over square root of 2 pi integral exponential raised to power minus. Now taking the LCM here, we're going to have x squared. Then these two multiply by this, we have minus 2 iota tx. Then everything divided by 2. Then we have delta x. So from this point now, so we want to use completing the square on this. So I will just ignore this for this moment. Then we deal about this. Just completing the square. Completing the square on this bracket that we have here, which is x squared minus 2 iota tx, then divided by 2. Now this, now we can also write it this way, which is 1 over 2. If you bring out this denominator, you have into bracket x squared minus this 2 will still remain here because we just factorize 2 out. So we have 2 iota tx. So 2 iota tx. Okay, so we're using completing the square on this now. We're using the square, completing the square on this x squared minus 2 iota tx dx. Now we should not forget that we have our 1 over 2 here. So simply now, I want to write this one this way. You can say 1 over square root of 2 pi integral exponential raised to power minus. Now this 1 over 2 that factorize, we have 1 over 2, and then into bracket x squared minus 2 iota tx. So now we are going to use the completing the square on this, just only this bracket now. And if we use it on just only the bracket, we're gonna have say x squared minus 2 iota tx. Now we say we have x squared minus 2 iota tx, then said plus into bracket x is the variable here. So the coefficient of x here is minus 2 iota t. So we're going to write it here, say minus 2 iota t, then we divide it by half. We divide it by 2, so we have over 2, then square all. So when we square all, we say this is equals to exactly what we have here. We're going to put it at the other side here. So into bracket minus 2 iota t divided by 2 raised to power 2. So which means when this cancel this, you can say if this cancel this now, we still have our x squared minus 2 iota tx left here. So we can write this one this way, say x squared minus 2 iota tx, and then plus into brackets. These two will cancel these two, and this square will take care of the negative. So what will remain here is iota t. So we have iota t raised to the power of 2 equals to, same thing here, we have a iota t raised to the power of 2. Now this is already a perfect completing the square. So these two now we can join them together. Now the sign at the middle here is negative. So we have a x minus iota t or raised to the power 2. This is what we want to achieve that make us to use completing the square. So if we open this bracket now, we're going to have exactly this expression here, x squared minus 2 iota tx plus it now equals to iota t raised to the power of 2. So if we bring this one in, we're going to have a x minus iota t raised to the power 2 minus iota t all square. So now this is the result of using the completing the square method. So this one we cannot slot in here. So we say we have a 1 over square root of 2 pi integral exponential. Now we have a minus 1 over 2. We already have minus 1 over 2 here. Then we say into bracket down all this value here now, say x minus iota t raised to the power of 2 minus iota t raised to the power of 2 bracket close. So for open this now, we can now have it since it is a raised to power exponential, raised to power exponential, we can, so now this will have a 1 over square root of 2 pi integral exponential raised to power minus 1 over 2. Then we have into brackets x minus iota t square. We can say this is plus, but we can manipulate it to have it as this way, say minus into bracket minus iota t square with this all we have here divided by 2. So we have the x. So now we can now write this, say 1 over square root of 2 pi integral exponential raised to power minus 1 over 2 x minus iota t raised to power 2 multiplied by exponential, separating these two, exponential raised to power minus bracket iota t raised to power 2 divided by 2. We have a minus here, iota t raised to power 2 over 2 the x. So we can just simply say this is going to be the probability mass function of the whole thing. We can say it is equivalent to 1 equivalent to 1 by derivative. Then we have exponential minus iota t squared divided by 2 as the characteristic function.